Okay guys, so this video, we are going to go over a few examples from the problem set called Adding and Subtracting Rational Expressions. So once you view this video, you will then go to that problem set next, okay? So make sure that you're following along. The questions that I'm going to cover in this section, I'm going to go over number 2, 7, and 14. Okay, so 2, 7, and 14, remember that the problem set has the answers at the end, so you can check your work, all right? So let's start with number 2. So the expression that we're given is m minus 3n over 6m cubed n minus m plus 3n over 6m cubed n. And at first glance, you're probably like, Schreiber, I don't even know what that means. Why are there so many m's and n's? It's okay, all right? Sometimes math problems, like we said, many of you on the survey said that you view math problems like a puzzle. So if we view this just as a puzzle, then the puzzle is giving us m's and n's, and our goal is to simplify it, okay? So from our previous video, we said that when we're adding and subtracting these rational expressions, we need to have a common denominator. So I have a 6 here, I have a 6 here. I have an m cubed, I have an m cubed. I have an n, and I have an n. These two fractions have a common denominator already. Now you may be wondering, well, why are you looking at this example? It seems like it's pretty straightforward. Well, this example specifically includes a property that many students forget. And even in my calculus class, my AP calculus students will sometimes make this mistake just because we don't always think of it, okay? So this first term, and I'm going to highlight this in green, okay? This first term, we are subtracting this whole term, m plus 3n, okay? So when I'm subtracting, let me go that, m minus 3n. I'm not just subtracting the m. I'm actually subtracting everything, m plus 3n. And you may remember from your algebra class that when I have a negative outside of this parenthesis, I need to distribute that negative. So now I have m minus 3n minus m minus 3n, and all of that is over 6m cubed n. All right, so let's see what I have. Now I have a positive m and I have a minus m, so those are going to cancel out. And then I have negative 3n minus another 3n. So that's going to simplify to negative 6n over 6m cubed n. All right. Now remember, in our last examples, we had one example where our fraction actually reduced. Okay. So let's think about what we have here. Can I reduce this anymore? Well, I have a 6 in the numerator and a 6 in the denominator. Everything's being multiplied together, so I can cancel out those 6's. I also have an n in the numerator and an n in the denominator, so my n's can cancel out. So what does that mean I'm left with? Well, I have a negative 1, because I've divided that 6n out, we have negative 1, over m cubed. And you might see this written as negative 1 over m cubed. And there's our final answer. All right. So why do we show that example? Because we want to remember that when we're subtracting, this negative needs to be distributed to each term if I have multiple terms. Okay, we can't just put the m, we can't just put the negative in front of the m, okay? All right, because if we would have done that, say we did that, we would have actually gotten something like this. M minus 3n minus m plus 3n. And if I look at that, I have positive n minus m, and I have negative 3n plus 3n. This would have just given us 0. So that's not right. So we want to make sure that we distribute the negative. Okay, let's go to number 7. Okay, number 7 is 6 over x minus 1 minus 5x over 4. All right, so common denominator time. Let's see what we got. So this denominator has an x minus 1. This denominator has a 4. So to even everything out, my left side I need to multiply by 4. And my right side I need to multiply by x minus 1. Because that's the term that isn't on the other side. Okay? So here we go. 24 over 4 times x minus 1. And I'm not going to distribute the 4 yet. I'm just going to leave it right now, just so that we can see where it's at. And I have 5x, x minus 1 over 4, x minus 1. So I'm going to keep simplifying this. So we have 24 minus 5x squared, because this 5x is getting distributed. And then there's another negative here. So when I distribute this second time, there's going to be a minus 5x. But also, remember from our previous example up here in number 2, what happened? This negative also needs to get distributed to both terms. So when that negative gets distributed to that negative 1, it actually turns it positive. And I have 4 times x minus 1. All right. And I'm going to simplify the numerator. I'm going to kind of clean this up. So we get negative 5x squared plus 5x plus 24. Oops. Over 4x minus 4. And at that point, if we check our work, remember, so you're going to go to the kind of scroll to the back side, and you will see that, yep, that is indeed our answer. They wrote it a little differently. They decided to not, the answer key did not rewrite it. They just kept it like this, and that's totally okay. Both of those are acceptable. All right. Okay, moving right along. Our next example, we said number 14. Okay, 14. All right, here we go. So we have 2 over 3x squared plus 12x plus 8 over 2x. All right. And I'm going to do something a little different, because this one, it's really hard to see what one term has and the other term doesn't. In our previous examples, it was easy to see here that this term had an x minus 1 and this term had a 4. So it was easy to see like, oh, okay, we see what the other one needs. But here it's kind of difficult. So I'm going to kind of manipulate this so it's easier for us to see what we need for our common denominator. So I'm going to start with the left side here. All right, and what I notice is that on the left side, both of these terms actually have an x in common. And when I have a term that's in common in that expression, I can factor that term out. So I'm going to rewrite this as 2 over x times 3x plus 12. And that is plus 8 over 2x. So now it's a little easier to see what each of our terms have in our denominator. Both terms have an x, so that's good. But one of these terms has a 3x plus 12, and one of these terms has a 2. So now I have a clear idea of what each term needs before I get my common denominator. So on the right side, this side is going to multiply by 3x plus 12. And my left side, we're going to multiply by 2. So let's simplify that. We have 4 plus 8 times 3x plus 12, and that is all over 2x times 3x plus 12. Okay, and I'm writing it like that. I'm not going to distribute everything into it yet. So let's see. Here's what we got. So we have 4 plus 24x plus 8 times 12 is 96. I think it's 96. This is where my brain is kind of in summer vacation mode. But yes, I am checking on my calculator because I'm never sure. And that's all right. Okay, so I'm going to simplify this because it looks like there's a lot of stuff in common here. So let's see. 96 plus 4, that's 100. So 24x plus 100. And I'm actually going to distribute this in this 2x. I'm going to distribute that in. So we get 6x squared plus 24. All right. Let's see, 24x, sorry. Let's look in the denominator. So in the numerator, what's in common with 24 and 100? Well, not much, but definitely a 2. 2 is in common up there. So if I factor out a 2, I'm left with 12x plus 50. And how about in the denominator? Well, 6 and 24, both of those have a 6 in common, and they also have an x in common. Remember that this is x squared, and there's one x there. So I have 6x and x plus 4. All right, I'm going to keep reducing, and my 2 and my 6, that's going to reduce to 1/3. So 12x plus 50 over 3x, x plus 4. And that is how we will see it in the answer key. Okay. All right. So if you guys are working through these problems and you may not get the exact answer, that's okay. You may have gotten to this point and you're like, whoa, Schreiber, like that doesn't look anything like the final answer. Maybe we need to simplify, okay? So don't feel like you're doing it wrong. Maybe there's just another step that you need to take to get to that final answer. All right. Okie dokie. See you guys in the next video.